This is the Chapter 6 review presentation covering all of the conceptual knowledge that we have done in Chapter 6. This review is primarily on conceptual knowledge. The review problems that you will be doing will then be on the responsibility of the student. So this is just going to basically cover the concepts that we've done so far in Chapter 6. I think I've got maybe 2 problems to work on. So similarity just basically means same shape, different size. So the angles of the shape will be all exactly the same, but the sides are going to be proportional. So in this case, I have these 2 quadrilaterals. The angles here are going to correspond, and be congruent to each other. The side lengths will be in a proportional relationship. Not exactly the same like the angles, but proportional. So let's take a look at writing a similarity statement because that's really important. So in this case here, one of the shortcuts we have is angle, angle, and I have 2 angles marked congruent to each other. I have angles A and D congruent, and then I have angles B and F marked congruent. So I can say triangle ABC is similar to triangle DFE. So again, A and D have congruency marks. They have to match in the same corresponding position. B and F have 2 congruency symbols, so B and F have to mark in the same position. And then angles C and E are just the last angles that come along for the ride, so they're going to be in the 3rd spot. So this is my triangle similarity statement. A triangle is similar, and the squiggly here means similar, to this triangle here. We have a scale factor for doing dilations. So this is when we have 2 similar figures. And well, this is not 2 similar figures. This is 1 similar figure being similar to itself. So I'm making a figure either bigger or I'm making a figure smaller. So when we show it on a coordinate plane, it looks like 2 figures, and maybe that's why it's confusing to some students. But this is in fact really just we took 1 figure and made it bigger or smaller. And since the prime marks here in blue are bigger, the triangle is bigger than the red one, that means I took the red figure and I made it bigger. So that's how that happened. And then the scale factor is done by taking the ratio of the lengths of the corresponding sides. And since the figures are supposed to be the same shape, it doesn't matter which set of sides you pick to do the scale factor. You just need to make sure you reduce the scale factor as much as you can. So a regular notation for a dilation is image over pre-image, and that's locked. Like you can't manipulate that or change it. It is always image over what it is over what it was, and that's so that if we make it smaller, the scale factor is less than 1, and if we make it bigger, then the scale factor is larger than 1. So an enlargement means it's going to be larger than 1. We have some similarity shortcuts. The first one is angle, angle. If I have 2 triangles and I have 2 sets of angles congruent to each other, the triangles will automatically be the same shape in different size. So in this case, in the triangle on the left, angles J and X are marked congruent to the triangle on the right. Angles K on the triangle on the left and Y on the triangle on the right are marked congruent. So then these 2 triangles are similar, and I can write a similarity statement as long as I do it in corresponding order. So triangle JKL, so going up and to the right, triangle JKL is similar to triangle XYZ, right? They have to match in corresponding order where we don't have similarity. Second shortcut is side, side, side. So if we can't measure any of the angles, we can check the side lengths. And if all the sides are proportional, then the triangles are going to be similar. So in this case here, if I take the smallest sides, I have 12 to 4. So this is basically, if I take 4 times 3, I get 12, okay? And then I take the medium sides, and if I take 5 times 3, I get 15. And if I take the largest sides here, 6, and take 6 times 3 and get 18, then I do have similarities. So these triangles are going to be similar to each other at a scale factor of 3 to 1, because the big one is 3 times the size of the small one. And then we've got a third similarity shortcut, and that's side angle side. So if I have two side lengths proportional, and then the angle between the two proportional sides are congruent, those angles are congruent, then I'm going to have similar triangles. So include an angle. So you notice here KL is 30, YZ is 10, so that has a 3-to-1 relationship. And JL is 15, and XZ is 5, and that has a 3-to-1 relationship. So these have numbers on them. The angle between the numbers here is angle L, and the angle between the numbers here is angle Z. So these are the included angles here. So angles K and J aren't included because there's no numbers here. Angles X and Y are not included because there's no numbers here either. So it's got to be the angle between the numbers that you're dealing with in order for side angle side to be a relationship you can use. So we talked about proportionality theorems. It's just a short time ago. So if I put a parallel segment inside of a triangle, I'm going to have proportionality. So in this case, I have a parallel segment here. So then A over B is going to be equal to C over D. And I can do that relationship horizontally as well. So I can go A over C equals B over D. So I can do it vertically or horizontally. I can go up and down, or down and up, or right and left, or left and right. I just have to be consistent in the direction for all four numbers. And we have a converse. So if I have proportionality, so if A over B equals C over D, then I know that this segment is parallel. So if I have proportionality inside of a triangle, then I know that the segment that's creating that proportionality is going to be a parallel segment. And then if I cross three parallel lines with two transversals, then I'm going to have proportionality inside of those gaps. So in this case, these relationships are going to be proportional. So AB over DE is going to be equal to BC over EF. And again, I have a horizontal relationship. AB over BC will be equal to DE over EF. If I bisect an angle inside of a triangle, I'm going to have proportionality as well. So I can go C over, so I have an angle bisected here, so I have C over D is going to be equal to A over B. And then I have a horizontal relationship as well. So C over A is equal to D over B. And again, I can go left, right, right, left, top, bottom, bottom, top. When you set them up, I really think you should set them up just how they look. So I really like this relationship here on the bottom. Just go C over D equals A over B. Just do them how they look, okay? And I think you'll be fine setting them up. All right, so this is the funky one, okay? If we are finding side lengths of parallel sides, then we have to use similar triangles. Okay, that's a huge, huge concept. And I have students who struggle with that, okay? If I'm trying to find the length of a parallel side, okay, then I have to use similar triangles. With all the other proportionality theorems, I'm not finding lengths of parallel sides. In this case, I am. So I have to set up similar triangles. Like that's what has to happen. Because I usually see students go like this length over this length. So A over C equals like this. They'll do like X over D. And they're always going to come up with too short of a length. D is not going to be long enough, okay? So you have to set up similar triangles. So it's got to be A over C equals a side length of a triangle. In this case, B is representing this entire length of this triangle. So this would be B over D. All right, so let's take a look at an example here. So use side, 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 angle, angle, or side, angle, side to show the triangles are similar. So when I'm trying to show triangles similar, I'm looking at the small triangle inside here, which is triangle CBD, and then I have the big triangle. So those are the two triangles that we're trying to show similar to each other. And I can't really use side, side, side because I don't know the side lengths of BD or AE. So side, side, side is out, okay? Angle, angle. Do I have measures of angles here at all? I don't have any angles at all. So angle, angle is out, and you might be like, wait a second, Mr. Kenyon, you don't have any angles at all, so you couldn't possibly use side, angle, side because it's got an angle. But I can. I can use an angle here because angle C is reflexive. Angle C is the same exact angle as the blue triangle as it is with the purple triangle. So I'm going to use side, angle, side. I'm going to start first with angle C. Angle C is going to be reflexive, so it's equal to itself. And then all I need to do to check for proportionality is make sure that these numbers work with each other. So 4 over 8 has to work with 3.5 over 7, in which case I'm just going to do cross products. So 4 times 7 is 28 when I cross product multiply, and 8 times 3.5 is also 28. So in this case, these triangles are similar because of side, angle, side. And you can have a choice, in some cases when you're trying to prove triangles similar, you can use whichever one you like the best. In this case, there's not really much of a choice because I don't know BD or AE, so side, side, side is out. I don't have measures of angles here and here or here and here, so angle, angle is out. In this case, I only had one option, which was side, angle, side. Okay, so that brings us to the end of the review presentation and all the concepts that I really, really want you to know for Chapter 6. So your assignment problems for Wednesday, I want you to do questions 1 through 6 on page 414. Hold on to it. And then on Thursday, I want you to do questions 7 through 10 and 12 through 13 on pages 415 through 416. When you're done with those two sets of problems, send them to me in an email. And then on Friday, I want you to do questions 14 and 15 on page 416 and questions 1 through 6 on page 418. And that'll finish up the weeks 7 and 8 of flexible learning. Now, if you want to get a jump start on the following week, and if you're kind of worried about studying for your test that's going to be coming up, because once we're done with this review, you're going to have a major Chapter 6 assessment, in which case then the following Monday, but it's not weeks 7 and 8, this will start weeks 9 and 10, you could start to work on that assignment if you wanted to. But page 416, I don't want you to send that to me. You won't send that to me until the following Monday with these two assignments and one assignment list sent to me. So these two you send in one assignment list, and then for this Friday here, you can hold on to it until we get into the following week. And then hopefully you will be well prepared to take the Chapter 6 assessment. Thank you very much for watching the presentation. I hope you found it helpful.